This is the screencast for section 3.5, example 3, jerk. I'm not calling anybody names, but this is the one time your book uses some sort of sense of humor. It's actually titled example 3, a couple of jerks. So hopefully you got a good chuckle out of that. But anyway, the third derivative of position is jerk. In terms of what that means, jerk is a change in acceleration. So if you're pushing the gas pedal slowly and all of a sudden floor it, your head's going to go back because you feel that change in acceleration a lot greater. You feel a jerk. Now, part A here says the jerk caused by the constant acceleration of gravity is 0. And what that means is if you drop something or if you, go bungee jumping, you're not going to feel a jerk when you jump off of the platform. You're going to feel a gradual increase in velocity, which is a constant acceleration, and therefore no jerk. Part B, the jerk of simple harmonic motion in example 2, when we found the acceleration, it was -5 cosine of t, so the jerk is going to be expressed as 5 sine of t. So this last part here talks about when you feel the most jerk, and that's where your acceleration changes direction and sign. If you are going forward in a car and all of a sudden throw it in reverse, I know you've got bigger problems than just going backwards. At that point your car is going to be fried, but you throw it in reverse, you're going to feel that jerk really, really intensely because your car is changing directions and your acceleration was going forwards, your velocity was getting faster forward, and now it's getting faster backwards. Alright, so now try problem number 19. A body is moving in simple harmonic motion with position function s. Find the jerk at time t. So they give us position, we got to go all the way down to find jerk. So we need to find the third derivative. Alright, position, the original function, is sine of t minus cosine of t. The derivative of position is velocity, so that's going to be cosine of t plus sine of t. The derivative of velocity is acceleration, so that's going to be negative sine of t plus cosine of t, positive cosine of t. And then last but not least, the jerk, then the derivative of negative sine is negative cosine of t, and the derivative of cosine is negative sine. Now to test those, I put all 4 of them in my calculator, and then I told the calculator to take the derivative of the first one 3 different times. By the time I got to the jerk derivative, it didn't like taking the derivative of a derivative of a derivative, so I just told it to take the derivative of what I knew was right. I knew y3 was right by my graph, so I told it to take the derivative of that.